Good morning, good afternoon, good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Vorhies, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. I'd like to start off our event today by thanking MariaDB for sponsoring today's event. MariaDB is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. Now, past webinars are available on demand at datasciencecentral.com, and if you haven't had the opportunity to view them, I encourage you to take a look. They provide very useful insight into a wide variety of topics of interest to our data science community. Now, today's webinar is entitled Columnar Databases, Best Choice for Real-Time Analytics, to be presented by MariaDB. Before we begin, I'd like to briefly review the format of today's webinar. Today's event will be an hour long. We have one presenter who I'll introduce in just a minute. There'll be 10 to 15 minutes of Q&A following the presentation. And this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation because we'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speaker, Shane Johnson with MariaDB. Now, Shane is Senior Director of Product Marketing. And prior to MariaDB, Shane led product and technical marketing at Couchbase. Earlier, he performed technical roles in development, architecture, and evangelism at Red Hat, specializing in Java and distributed systems. So Shane, hey, thank you for being with us today. We're looking forward to your presentation. Now, business today often calls for analyzing millions or even billions of rows of data on demand and in real time. And although relational databases are unmatched for transactional workloads, columnar databases allow for faster and easier analytic queries. So in today's Data Science Central webinar, we'll explore how columnar databases can decrease the need to read from disk, massively compress your dataset, eliminate the need for indexes, and support ad hoc on-demand queries at any scale. So we'll use MariaDB AX, an open source columnar database for enterprises, to demonstrate how column-based storage can make your analytics more efficient, flexible, and scalable without sacrificing standard SQL. So Shane, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Thank you, Bill, and welcome, everyone. So before we start diving in a little bit deeper, I wanted to spend a little bit of time to talk about, transactional versus analytical, since we kind of opened with analytics are better suited to columnar databases. Now, this is a little bit of a generalization, but the way I look at it is that most transactional workloads tend to have predefined queries. Developers have built those applications, and along the way, they've identified the queries that need to be ran. They're often point and range queries. Get my profile, show my recent purchases, display a product, find products in a category. Ideally, despite how large that data set might be, you're probably returning a small number of rows. And because of all of this, there's usually lots of indexes, hopefully not too many, but enough to make sure that all of those predefined queries run very well. On the other hand, as you start to steer into analytics, you also have more traditional data warehouses, often for BI and reporting. I would say there's still mostly predefined queries, particularly if someone's building a data warehouse or a data mart for very specific reports. A lot of range aggregates for the most part. Maybe a medium subset of the data, depending on just how much you're looking at. But if it's the last week, the last month, revenue by quarter for the last 2 years, we're still looking at subsets of the data and a handful of indexes to make sure those queries work right. But when I talk about analytics and MariaDB AX and columnar databases for the duration of this webinar, I'm really talking about ad hoc, on-demand, interactive analytics, right? You don't know how the data is going to be queried. Data analysts, data scientists, they're going to, iterate over this and experiment and search for things. You're going to do a lot of aggregates, quite possibly on a lot of the data, if not all of the data. And ultimately, no indexes. And that no indexes kind of goes together with the unforeseen queries part. Because if you don't know how the database is going to be queried and how the data is going to be analyzed, you're not really in a position to create an index for every potential query that happens. And a couple examples down there. But for analytics, the difference being I might want to look at the average shopping cart life for all time. How long does shopping carts open until a customer finally purchases or doesn't purchase? In that case, as Bill was just mentioning, you might be querying billions and billions of rows, but you want to get those results back in a second, very quickly. So when I say analytics, it's largely around this last option here. Before we dive into the agenda and go a little bit further, though, we have a short poll here. I thought it might be useful to get a bearing for what everyone might be doing today. So this is, what database are you using for analytics? Any type of analytics, I think, for the purposes of this poll. It could be just a traditional relational database, something from an Oracle or IBM or Microsoft. It could be more of a specialized proprietary data house, a data warehouse like Teradata. Or maybe you already have some familiarity because you're using a Vertica or a Greenplum or some other columnar database. You could be doing something in the cloud with, say, an Amazon Redshift, or maybe it's Hadoop, for example, Hive, or any of the other Hadoop components for that matter. But we'll leave this one open here for a few seconds here, because I think it might be nice to just get a feel for what everyone's doing, and particularly if you're using columnar databases or not. That can help steer a little bit of this presentation depending on what you're using. So we'll leave that open for, say, another 10 seconds here, and then we'll take a quick look at the results and dive right in. So it looks like the majority of everyone is just using a very traditional proprietary database to do their analytics. I'm guessing that sometimes it's deployed with a star schema or some other ETL to help kind of mold that into something that services analytics better. But certainly majority are there, with the next group kind of split between specialized data warehouses and some newer cloud data warehousing options. And then a slightly smaller group using Hadoop, and an even smaller group using columnar databases. So you're definitely in the right place, because we're going to talk about columnar databases quite a bit here. So for the agenda, we're using MariaDB AX as our reference for columnar databases. So I'm going to give a very light introduction to that. And then what I'm going to spend the bulk of this time on is diving into the architecture to show how it works. And hopefully that's very helpful to everyone. And depending on how much time we have left, we'll kind of go through some of these use cases by industry and a few customer success stories so that we can show you how it's being done in the real world. So for MariaDB AX, you may have heard of MariaDB before. MariaDB server is one of the most popular open source databases in the world. But from an enterprise point of view, it kind of goes into two different directions. On the left, MariaDB TX is really the enterprise solution for transactional workloads. And we do this through storage engines. So InnoDB is our default storage engine. That's a really good kind of mixed right, transactional storage engine. MyRocks, developed by Facebook, is for write-intensive workloads. And Spider is built-in transparent sharding. So if you need much higher degree of scalability, Spider gives you that. On the right, the other solution is MariaDB AX, and that is the enterprise solution for analytics. So that still is built on that InnoDB as our default storage engine, but it adds column store. And that's our columnar storage engine. And that's what we're going to be talking about today, and that's what makes it optimized for doing analytics. So MariaDB AX, I'm not going to spend a lot of time here, but some of the key aspects are that it's distributed. So for a scalability point of view, it has to be distributed. As I mentioned, it is columnar. It also utilizes parallel processing for performance. So when we talk about analyzing billions and billions of rows, we're going to need a lot of parallel processing to do that very quickly. And then we have this notion of data adapters and connectors, primarily to get data into your analytical environment, and hopefully give you enough flexibility to do that very easily. And then, of course, being MariaDB, it has to be open source, and it has to be standard SQL. So the very same SQL queries that you could run on MariaDB server, MariaDB TX, are the exact same queries that you can run on MariaDB AX. We're not going to take things away like joins or user-defined functions or anything else that might limit your ability to analyze that data. So we'll get into the architecture here. MongoDB, as I mentioned, is a row-based storage engine. So we're essentially storing, every row together in one big file, maybe file per table, depending on how you have it configured. This can be challenging. If I just wanted to get an average of one of my columns, and let's say I have 50 columns, I could be writing, 200 gigabytes of data. And if I just want to get an average of that one column, I have to read the entire 200 gigabytes of data from disk. Although maybe some of it's cached in the OS page buffer and elsewhere. But when you get down to it, because of that nature of being row-based, if we're looking at the value of a column in every row, we have to read every row. That's highly inefficient. So what we added was this new storage engine, Column Store. So kind of in the core database at the top, there's kind of this virtual storage engine. We call that Column Store. And then outside the database is the storage engine. That storage engine stores data by column. So if you're looking in the bottom right there, we can imagine that each of those columns is its own file. So 50 columns, 50 files, could be more depending on how big your data is. But for the time being, let's assume we have one file for each of those columns. If we ran the exact same query, depending on how big these columns are, but let's assume that there's 50 of them, they're 4 bytes each. Now we only have to read 4 gigabytes of data to analyze that data. That's a big difference when you think about performance. Reading 200 gigabytes of data versus reading 4 gigabytes of data. Much, much, much faster. So a whole couple notes about the Column Store storage engine. It has very high compression. And this, of course, has to do with being organized by column. In the real world, we see anywhere between 65 and 95%. So we've seen customers whose data set is about 1/10 the size when stored on disk. Also, being columnar is very well suited to sparse columns or no columns and many columns. So you are free to create tables with hundreds of columns, some of them null, some of them not. That's not going to interfere with performance. It's actually well suited to that. Because of all of that, there's no need for indexes. And we'll kind of go into that in a minute here on why that is not necessary. But the big benefit of not having to worry about indexes is that ad hoc on-demand analytics. We don't have to be prepared for every possible query. Whatever the data analyst or the data scientist wants to do today, the database is going to be ready for it. You don't have to worry about managing that aspect. So from a physical implementation, we'll break this down a little bit. Each column we call, in our terminology, a segment. And that segment is a file. Within a segment, we have this notion of extents. And those extents are basically logical groupings. And an extent has 8 million rows. So if we think about that first column, we're going to create a file. It'll have the values for the first 8 million rows as an extent. The next 8 million rows become another extent, and all those extents are grouped together in segments. Reason for this, one little thing that can help with performance, is that by having those logical groupings we refer to as extents, we track the minimum value and the maximum value within each extent. So if you look on the left side here, if we were to do this query on column 1, and it's looking for values between 220 and 250, we can very quickly look at the extent metadata and identify, do any of these extents actually have a value that falls within that range? And we determine that, hey, extents 1, 2, and 4, based on their min-max values, they can't possibly have what we're looking for, so we'll check extent 3. And that's another way we can reduce disk I/O even further. So not only were we able to limit disk I/O to a specific column, but within that column we were able to limit it to a specific extent. Alternatively, on the right, we determined that it couldn't possibly be anywhere. So there's not even a reason to do any I/O. So this is just one of those things that we can do along the way to keep improving performance without having to worry about indexes. Now, from kind of architecturally and deployment standpoint, that upper half, that's MariaDB server, that's the core database, that's the InnoDB storage engine, that's that column store interface. We refer to that as a user module or UM. So you might hear me use those terms interchangeably through the rest of the webinar. On the bottom, the actual storage engine itself, we refer to as the performance module. When you're first getting started, if you're running this on your laptop, for example, you can install the user module and the performance module together. They'll sit side by side, and it's very easy to get started. Once you start to get a little bit more serious about it, you'll want to run the performance module separately. They could be in 2 separate containers, 2 different physical servers, 2 virtual machines, but you're going to want to separate those out a little bit. And we'll kind of explain why that. Let's assume we have a query, and it takes about 90 milliseconds. And to keep the math easy, I just said we have 300,000 rows here. The reason we want the PM separated is because we can add more of them. And so if we started out with 300,000 rows on 1 PM and we added 2 more PMs, we can then redistribute that data so there's only 100,000 rows on each PM. And since we have 1/3 of the data, that query should execute in 1/3 of the time. It's going to only take 30 milliseconds on 3 nodes concurrently, essentially making my query, bringing it down from 90 milliseconds to 30 milliseconds. Now, the way it also works, worth noting, is we do push down. So as much as possible that comes in through that core database, we'll push that logic down into those PMs. And so if you're doing an average, much like that one I did in the very beginning, we'll push that average function down into each of these PMs. Each PM will execute that function on its local data set. So maybe, the PMs, the first 3 return 50, 60, and 70. They'll push those values up to the database, and then the database will then average those 3 values to return your results. Now, the other thing we can do is scaling up to a certain degree. Column Store is very well suited to multi-core hardware. So if you have 12, 20, 48 core or higher servers, that's great. Instead of sending that query, one instance of it to each of these PMs, we'll break it down into lots of little instances and send it to all those PMs, because then we can execute it in a multi-threaded fashion. So since I ran out of room here, you only see T1 and T2, but you can imagine maybe we're sending 3 parts of that query to each one of those PMs, or though in practice it could be a much higher number. But ideally, those again run even faster. So instead of running 30 milliseconds, each one of those is running in 10 milliseconds, bringing our query down even faster. So there's 2 ways to scale MariaDB AX. Certainly on that bottom part, we're looking at either a storage capacity, right? You just have so much data, it's not going to fit on a single disk, or query latency, right? Because the more processors we can use, the more disks we can use, the more memory we have available, we're going to be able to speed up that query. On the top part there, in the user module, really around query throughput, right? So each of those databases is going to be able to handle so many concurrent analytical queries. But if you have more users and you're executing more concurrent queries, then you can add more user modules. Typically, you have a handful of user modules and a lot more peer performance modules, depending on your performance and storage requirements. The next part of it really comes down to how can we get this data in MariaDB AX, notably SQL. So this isn't a read-only system. You can, of course, write all of your queries in SQL. You can also insert, update, and delete data via SQL as well. So if you have small updates coming in incrementally, that's an option for you. But of course, SQL is not a particularly great way to insert bulk data. If you're getting data from different sources for analytics and it's getting rather large, we're talking, maybe terabytes of data at a time, SQL, not a good way to go. So we do have an import tool. This is your typical kind of command line import interface. If you have a CSV file, for example, you could use that import tool to import the data directly to those performance modules, which is great because you want to bypass the SQL parser, optimizer, and executor and go straight to storage. And by straight to storage, I mean we're really writing straight to those files. So before I mentioned that each of those columns is a file, well, we're just going to open those files and we're going to import the data directly in those files. Much, much faster. And because this is not an index-based system, we don't have to worry about updating indexes when we're adding our data. You can further improve it. In the previous example, we assume that you have one CSV file and that maybe you're importing it from a user module. But if you're able to break up that file and put it directly on those performance modules, you can do the import directly from there and it's even faster. So if performance is a concern, you can actually go this route and insert data at a ridiculous rate into this environment. Next was the data adapters. And I talked about this a little bit early on as one of the key components. We had this notion where it's really important to get data into an analytics environment as fast as possible, especially from a business point of view. They're going to talk about things like faster time to insight, faster time to action. You want to be able to have data ready for analysis as soon as that data arrives. And what we kind of saw was that people were, using these import tools. They were scheduling cron jobs, copying files. Ultimately, it was a little bit of a brittle system, right? They kind of hoped it worked, but you had to keep a close eye on it. Often, especially if it was through scheduled jobs, the data could be days old, it could be a week old. So we wanted to give folks the ability to get data directly into MariaDB AX without having to worry about the administrative part. And so we created this notion of bulk data adapters. These bulk data adapters allow people to write everything from Python scripts to Java services to basically import the data themselves. So for example, if we were collecting clickstream data, we might have a RESTful service that simply gathers this clickstream data and basically inserts micro batches into the analytics environment. On the other hand, we had a customer who was receiving genetic data on a regular basis. So they wrote their own Python scripts to parse that data and put that into MariaDB Column Store. And it was important because that data was not only made available to their own data scientists, but it was made available to their customers. And in a highly competitive environment, it wouldn't be acceptable for them to make week-old data available to their customers, particularly in this industry. Their customers wanted data that was 5 minutes old. So the bulk data adapters give you that flexibility. The Spark connector, probably fairly obvious, especially to those of you who said you were using Hadoop in that poll. But yes, if you prefer to do your machine learning in Spark, you can do the magic you do there and then publish those results directly to Column Store. And so if we start to kind of pull this all back together, we have these user modules at the top. And that's the core database. That's where all the query parsing is happening. You have those PMs at the bottom. That's our distributed storage, parallel processing. You can get data through CSV imports. You can get data through bulk adapters. You can get data in through SQL. The one I didn't mention yet was the streaming data adapters. And we have two. One of them is for Apache Kafka. So if you're in a distributed messaging type environment and you have one or more Kafka queues, we can tap into those queues and continuously pull those messages down and insert those into the performance modules. Or we have this notion of max scale CDC. So very, very early on, I mentioned that we had MariaDB AX for analytics and MariaDB TX for transactional. If you have both, MariaDB TX has a change data capture protocol, and it will stream all changes to the transactional side automatically into MariaDB AX for analytics. So in either of those cases, Kafka or max scale CDC, depending on the performance all around, you could have data that is as little as seconds old, maybe a few minutes old. And you can imagine the power of that from an analytics standpoint when you can tell, the data science team at any point in time, you're analyzing what is nearly the most current data we have. You don't have to wait for an import. You don't have to wait for a scheduled job. You don't have to wait for an ETL process. It is ready for you at all times. And there was one part that I added to here at the end that we didn't really cover, is that MariaDB server in MariaDB AX, it still has NODB, which is that row-based storage engine. So one of the things we often remind people of is that you can mix and match both row-based and distributed columnar data. And so I did a quick little example here where think of a financial institution. I have, say, 50 million customers. Not a terribly large amount of data. We could probably get away with putting that in NODB on our user module and making that available. But then think about the transactions for credit card users and trading and mortgages. There could be, I put 100 billion here. There could be much more than that. It could be hundreds of billions of transactions, in which case you're not going to be able to store those in an NODB. So you can push those down into Column Store, distribute those across as many performance modules as need. And then when you start to do more analytics around, how often do people buy things, or based on, where people live, what's the average spending price, what's the geographical radius, and you can join that data. So you can do joins between all of that distributed data down below, and then all of that row-based data stored at the top. So if you think about star schemas, for example, with facts and dimensions, those type of models can work really well in MariaDB AX, in addition to more, say, denormalized tables, where you're just kind of taking a complex schema and you're ETLing it into maybe just one big table. So we still have a little bit of time remaining, so I'm going to go ahead and spin through some of the use cases, a little bit of what our customers are doing. Please do be asking questions throughout the presentation, and I will certainly make sure that we have time to go over those. Financial services. For each of these industries, I'm not going to spend a great deal of time going over kind of the industry use cases. I imagine the slides will be made available to everybody, but I will point out some of the places where we're seeing the relevance with our customers. And I think down here on use cases is probably the point of focus of fraud detection. And this isn't maybe limited to financial services, but it's certainly an example use case where it's really about identifying patterns and detecting anomalies. In this industry, it would be of financial transactions, but in other industries, it could be of other data. Another one that we see is compliance archiving. And it kind of, I think, implied by this notion of archiving is that they have to store more and more data, not just the data from this month or this year, but the data for the past 5 years or the past 7 years. And as they grow and have more customers and generate more data, that becomes more challenging. And then it's certainly forecasting, maybe kind of getting the heart of analytics of looking at the data we have from financial markets, transaction history, securities that we're holding on to, trying to figure out what's going to happen in the future. I once did some work with a bank a little while back where they were on a daily basis analyzing all of their investment accounts to predict what would happen if there were another economic crash. So what would happen to the mortgages we're holding? What would happen to the credit card debt? What would happen to, people with 401ks and other types of accounts. I did this every single morning to prepare for a sort of worst case scenario. And the particular customer example here is ODC Markets Group. And they kind of fell into that camp, two camps really. One of them was the compliance archiving, and the other one was really kind of more the analysis and predicting what's going to happen. But what happened is they needed to store up to 5 years of data now. And so they're right around 10 terabytes of rolling data, kind of growing continuously. But point being, they certainly had to store more than originally planned. And then they also had, you could see about 24 million quotes. And kind of one of the issues that was happening here is that, one, they wanted to make this data available for analytics from their own customers. So people that were their customers could come in and they could analyze all the data they have around trades and quotes and securities. And you don't always know how they're going to do that. The other issue is they had to allow regulatory agencies to come in at any point, with very little notice and build their own reports on the data. And so in either of these scenarios, it's not really feasible to create all the indexes to support any potential query that an agency or customer might want to run to analyze the data. And so moving to an indexless system was a big driver for these folks. The next one is healthcare, and this is a particularly big one. And again, kind of looking at the bottom, big use cases, population health management. So we're starting to see organizations who are gathering massive amounts of healthcare data. It could be something as granular as, patient surveys and claims, to those things, the electronic health records, but as much data as they possibly can, and then trying to analyze it to better understand health of any given population. And that's the one that we're going to talk about here in a minute. And also precision medicine, so a lot more genetic analysis. And we're also seeing this where people are coming in and storing data around genotypes or other types of genetic data and then doing analytics on that. But for the customer, in this particular case, is the Institute for Health Metrics and Evaluation. So they have this report. It's the Global Burden of Disease. And it came out some number of years ago. The very first reports were a little bit on the small side. Probably, I would say, a terabyte of data at the most. Probably less than that, actually. But even when they reached a terabyte, they were having a little bit of challenges around, what's the best way to keep growing and to keep extending this report. And so they were using MySQL at the time, and they started looking for alternatives that would allow them to be a little bit more efficient. Compression was really kind of the big driver at that time. We have this data, we know it's getting bigger, but we're looking for a database that can store it, smaller and smaller, because it'll, the hardware we have will take us a lot farther. Well, needless to say, they update this report every couple of years. It did grow to a terabytes, and then 10 terabytes and 20 terabytes. They're at 30 terabytes of data now. Probably be significantly bigger with the next report. They have 10 tables, each table with 10 billion rows. So we're looking at about 100 billion rows in this example. And what they've done is they've gathered all of this health data, and they've actually made it available to the public. And so on this particular slide here, what you have is kind of a screenshot of this website. So if you search for IHME and the global burden of disease, you can find a link to this. Is available to everyone, but you can interactively in real time analyze those 100 billion rows that I was mentioning. And it happens as fast as you expect any web page to load. You can see on the left there's different parameters and different things you can change. Hit that button and it revisualizes the data for you. And that's really what we're getting at when we talk about the heart of ad hoc interactive analytics, is placing 100 billion rows in front of you and letting you visualize random queries in real time. That's very powerful. Telecommunications is certainly another one. I think what here probably what we see a little bit more of is churn prevention, kind of cross-selling, a strong desire to look at how customers are using the hardware and services that's available to them, and then seeing what can we do to make sure that they stay customers. Why are they going to leave my network to go to another network? What can I do to keep them here? Can we bundle things? Can we understand that they're not actually using as much data as we sold them? So maybe we should offer them something lower. That's what they're really getting at. Down to some other ones, which is more along the lines of looking at the traffic, the cell towers, networks, hardware, to better allocate investments going forward. Where should I build a new cell tower? Or merge two cell towers? Where should I invest? Where should I stop investing? That's what we're trying to get at there. And the example here is Pinger. I don't know how many of you may be familiar with Pinger or not, but Pinger builds mobile apps for text and chat. And so in their database, they started out using MySQL as well. And I think they had maybe 6 months worth of data. But they really wanted to be able to store up to 2 years of data. And that shouldn't be surprising because they're trying to analyze customer behavior. 6 months is not a lot. If you can get to a full 2 years, you can definitely get a more accurate, better understanding of how customers are using your apps. And certainly when you're doing 1.5 billion logs a day and tens of millions of phone calls and texts, that's going to be growing fairly quickly. So they moved to MariaDB AX, particularly from a scale point. So being able to scale from 6 months of data to 2 years of data, and also because since they were an existing MySQL user and MariaDB AX supports the MySQL protocol, they could move to MariaDB AX without having to rewrite their applications and do a lot of work in that regard. And the last one here is digital advertising. And I think the most common one for digital advertising is audience segmentation or profiles. So every day we're on the internet, we're Googling and searching and visiting websites. Those advertising networks are gathering clickstream data and other data about you. Hopefully, if I'm browsing, they know that I like science fiction, that I live in California, that I'm married, that I like audiophile equipment and speakers, and they learn about me, and because of that, they can start making better recommendations on the ads for me. And so, one of the customers we had, they were doing this, and they're pulling in hundreds of millions of clickstream events per day. So they're growing really, really, really quickly. And the problem that they had, provide all of their customers the ability to analyze the data themselves. So this is really, how would I describe it? This is a platform, and that platform is made available to other very big organizations who want to run their own advertising. So in their earliest point, which was, I would say they weren't even migrated all the way to production, but rather maybe a sliver of their production traffic was being moved to MariaDB AX. They were already at 60 terabytes of uncompressed data. And doing about 300 million impressions a month, and more importantly, 70 million rows a day. So you can kind of think about the scalability that if you have, 5, 10, 15% of your traffic generating 70 million rows a day, happening nonstop, from a scalability standpoint, they're going to have to start storing lots of data. So compression was a very key factor in their search for a new solution. The other one is that within this platform that they've made available to their customers, there is an interface for them to build their own analytic reports. And so they're able to choose any combination of up to 30 columns to build these reports. And they're also in a situation where they don't want to create and manage indexes for all of these possible permutations across all of their data set that customers might want to build. It's not something they want to worry about, not something they want to manage. So the other kind of driver was moving to a database that didn't require indexes. So they could still meet the performance requirements of ingesting all of this data and still meet the performance requirements of providing their customers with real-time queries, but they didn't have to worry about the management headaches of maintaining indexes and worrying about what that query performance is going to be and whether all their SLAs are going to continue to be met. So hopefully that was a pretty helpful explanation of MariaDB architecture, how columnar storage and distributed processing is used, and how some of our customers are using it in different industries. But with that said, I'm happy to turn it over to you, Bill, for moderation and spend a little bit of time here to answer any questions we might have.
Well, Shane, thank you for that excellent presentation. And let us move on to this slide. So we'll get started with today's Q&A session. I want to thank the audience for their participation. We've had a lot of questions that have come in, and we'll do our best to get through all of them in the time remaining. And during the QA session, I'll leave up this screen with contact information for Shane if you'd like to contact him following today's webinar. So let's go ahead and get started. Shane, the audience is interested. Is MariaDB AX open source and available to everyone? And is that also true of TX, the transactional side? AX open source and available to everyone, and is that also true of TX, the transactional side?
Yeah, that's a great question. So MariaDB server is, of course, 100% open source, as is that Columnar storage engine. That is also 100% open source. So anybody is welcome to go to MariaDB.com and try these things out. What's different within an enterprise subscription is you get a few additional tools. Some of those streaming data adapters, for example, or on the TX side, that max scale change data capture protocol handled with an advanced database proxy. So there are additional tools that fall under the BSL license, but the core databases and the core capabilities, those will always remain 100% open source.
Well, Shane, thank you. Now, the audience is also interested to hear you compare MariaDB AX to other Columnar databases. MariaDB AX to other Columnar databases.
Yeah, I mean, I think architecturally, it's going to be very similar to a Vertica or a Greenplum. I think functionally, it's going to be very similar to them as well. You might find a few more bells and whistles in a proprietary solution like Vertica, but the core capabilities that people are looking for, those are available in MariaDB AX. And we'll be extending those capabilities with the next release, which is not too far away.
Okay, and the audience has also asked specifically about Mongo and how would that compare?
I think I was on mute there for a minute.
Okay, the audience has also asked specifically about Mongo and how would that compare?
Yeah, you know, I think MongoDB, you know, is certainly well suited to, you know, probably transactional workloads with semi-structured data. But by the very nature of what it is, it's not going to be something where, how would I describe this? I wouldn't be doing analytics on massive data sets in MongoDB, particularly because even it isn't going to be able to benefit in the same way that Columnar storage is, right? You're still going to be reading too much data from disk. Outside that, it also tends to be a little bit more oriented towards working sets that fit in memory. So it certainly scales, but ideally your working set, which is that smaller subset, most, if not all of that fits in memory. Sending it an analytical query on the entire data set that will like you have to read that entire data set from disk is probably going to be pretty punishing. That would probably be my best guidance in that regard.
Okay, well, thank you very much. Now, here's a fundamental technical question that I think will help the audience. And the audience member has asked, well, is OLAP the same thing as a Columnar DB technology?
You know, I think conceptually my instinct would probably be to say that they're a little bit different, but I think that's probably going to be a little subjective and kind of depends on how you define things. You know, when I think of OLAP in my background, for me personally, that meant, you know, way back in the day, having data warehouses built to meet, you know, certain queries that were, you know, largely reporting based. So reports that were ran every day, every week, having a data warehouse built to support those reports, and then having it updated on a regular basis. For me at that time, you know, I would have thought of that as being kind of in the OLAP type of space. That was some time ago, though. Today, when I think more about analytics, I definitely think more ad hoc, more interactive, unknown, unforeseen, iterative, just really, you know, digging in and trying to discover something within that data. But maybe there are folks out there who, you know, as analytical capabilities have evolved, maybe that definition of OLAP has evolved as well. I think that would be actually maybe a question I'd, you know, probably turn to everyone attending here is how do you look at OLAP and modern analytics, and whether they're the same or whether there's kind of a generational difference there. But that's probably the best I can offer.
Right, that's an interesting nuance. A fairly technical question. The audience is wondering exactly where and when are the extents created, and are the extent metadata created in the user modules kept in memory?
That's a really good question. I'd have to check on the in-memory part. I'm not sure if it's stored, if it's cached in memory or just stored on disk, but certainly something we can catch up with offline. But the extents are essentially created as the data is growing. So data is kind of striped across those performance modules. And so as it fills up an extent on one, it'll fill up an extent on the next one. And so on. So they're created as, you know, essentially you reach those 8 million row milestones and have a new one be created. Hopefully that helps clarify. If not, feel free to follow up with another question.
Sure. And an additional technical question, this one about the performance modules, and that is, do the PMs do redistribution that allow for rebalancing?
Yes, you can rebalance the data when needed. So for example, if you are adding more PMs for scalability or performance reasons, you can rebalance the data. Rebalancing data is always a little bit of an expensive operation. So I would certainly exercise a little bit of, I don't know if I would say caution, but planning. Plan, you know, when you want to rebalance that data. Because certainly a little bit of work has to be done. I mean, there's going to be a certain amount of both disk and network I/O to shift that data around. But absolutely, of course, you can do it when the number of PMs changes in particular.
Well, Shane, thank you. The audience is asking for specific comparisons between MariaDB AX and Microsoft BI, as well as Azure Data Warehouse or AWS Redshift.
I'm not closely familiar with all of those. I am a little bit familiar with Redshift. I understand what it's built on was licensed and is a little bit aging now. So I think you would find that MariaDB AX is similar, kind of in those core architectural components, but newer in its capabilities and newer in its efficiencies. So certainly you'd be able to do a lot of the same stuff, but you'd probably be able to do it faster with MariaDB AX. Certainly that's something that, depending on how often you're upgrading or when you're kind of jumping into it, AX is a product that is continuously being improved upon very frequently, whether it is the Columnar storage or new data adapters or new built-in functions. I think you'll find that it's a project with a very healthy, very vibrant and active development going into it versus something that's starting to be a little bit aging and just kind of still out there.
Well, thanks for that response. Now, the audience is interested to know, wants to talk about high availability and scaling. So, for example, how does the scaling capability of MariaDB AX compare to Cassandra? And exactly how does MariaDB AX handle high availability?
Great questions. I would say in relation to Cassandra, on the dimension of scalability, probably similar, although I haven't pushed it as high as I've seen Cassandra pushed. I think for people whose data sets are in the tens of terabytes to hundreds of terabytes range, really comfortable. I don't have any, I haven't heard any feedback from people pushing MariaDB AX into beyond a petabyte. So in that case, that might be a good kind of marker for you, even if you're looking at Cassandra, is just how big is your Cassandra deployment. If you were thinking about scalability in terms of, say, as low as 10 terabytes to as high as several hundred terabytes, that's still within MariaDB AX comfort zone, and not necessarily needing maybe a Cassandra or Hadoop or something that kind of can move potentially into the petabytes of data. But on that topic, I think the big difference is that Cassandra is essentially a table query model. So however you want to query that data, you're going to have to create a table with that data. And sometimes that can mean having lots of redundant data. So if you're querying the same data in many different ways, you essentially have to have it replicated in many different tables. And really, you're kind of working without SQL. It might be a little bit out of date here. I know Cassandra kind of had CQL, and I know they kind of supported the select part of the statement. But when you're looking at joins and aggregation and all these other capabilities, you're going to end up doing without those kind of in a Cassandra world. I think what's changing a little bit, and this isn't just about Cassandra, but something someone else had told me the other day, is this notion of now that we're getting databases that can scale and provide the performance and the richness that we're looking for, we don't necessarily have to pre-compute results anymore. And so I think that's kind of a difference is when you look at cubes and other data models are built on this notion of let's aggregate things ahead of time and then store the aggregate results and then let people query those because it's going to be faster. But now we're entering a territory where it's not even necessary to do that pre-aggregation or the pre-compute. You can actually run those queries on the raw data in its original form with the same level of performance.
Well, thanks. And maybe at this point, since we've done a bunch of very specific comparisons, we ought to just generalize a little bit and let you tell us, what kind of data models and queries work best on MariaDB AX.
Yeah, I think queries, maybe I might invert that a little bit and say it's not so much it works best, but where it's really going to shine, where you can really take advantage of it is sending it queries that are touching small number of columns on potentially massive number of rows, right? Don't hold yourself back. If you have a couple 100 billion rows and you want to do some sort of aggregate on a handful of columns, go for it, right? You can get that response back right away. And depending on that response, if you want to change it around a little bit, maybe drop one of the columns and add one of the other columns, then do that, and it's really fast. And so I think, being able to do, sort of queries looking at most of your data is where you should be. Sometimes I talk to folks and the workload is still leaning a little transactional, right? They're doing some work, but it's still on, some small subset of the data. That isn't maybe necessarily, you're not getting the most out of it, I would say, if that's what you're doing. Other things might be star schemas work well. Snowflake schemas could be more challenging. So in that kind of one I showed before, that row-based data was kind of centralized in a user module, and then the columnar data was distributed below. What can be challenging is joining distributed columnar data against other distributed columnar data. You can do that, but joins between two distributed data sets, of course, there's a lot of overhead involved in that. So if you can take advantage of either a star schema by compiling NODB and column store, or denormalizing your data into one big table, that's probably a little bit more recommended. I've seen customers with 200, 300 columns achieve ridiculously speed that they weren't able to do in their previous data warehouse. So it's pretty flexible in that regard. I'd say it's more about, are you really taking advantage of it and everything it has to offer? Because if you're being a little conservative, maybe not, right? Be aggressive, store lots of data, analyze lots of data.
Right. Well, thank you. Now, the audience has an interesting question. Since MariaDB AX seems to be optimized for read and fast accumulation of analytic results, what about fast insertion? If I have lots of changes and reads on my TX side, will they find their way into AX quickly, or what limits?
Yeah, so it sounded like we're talking about a scenario where you have both MariaDB TX for transactional data as well as MariaDB AX, a very write-intensive workload, and it's being streamed over. Is that going to be fine? The short answer is yes. I mean, certainly, the CDC protocol is built to help with that, and certainly inserts into MariaDB AX are quick as well. So even when we're doing that CDC streaming, there's actually some micro batching underneath, so it doesn't literally insert each individual streaming event into AX. It actually batches them up a little bit and then inserts the whole batch. But the other thing maybe to keep an eye out for really has more to do with the complexity of your schema. You don't necessarily want to stream every table from TX constantly into AX. So if you had a schema with thousands and thousands of tables, and many of those are small tables, then probably keep those in NoDB even on AX. And if you need to move some stuff into column store, it should be your bigger tables where that kind of distribution helps out. But yeah, I think that's the part to think about is how complex, how many tables do you have, and how many of those tables need to be moved over. And of those tables, how many can just go into normal NoDB versus how many need to go into column store for scale and analytics. So a couple little factors there to help guide you, but the short answer is certainly yes. It'll make sure that you're up to date.
Well, Shane, thanks. Great answers to some very good questions. And for those of you that asked questions today that weren't answered, we'll be sending all the unanswered questions to Shane and MariaDB team so they can follow up with you after today's webinar. I have just a few quick announcements. If you'd please mark your calendar for September 25th, that's our next DSC webinar, which will be 4 ways to tackle common data prep issues. Also, today's taping will be available for on-demand viewing later today, and you can find that on the homepage of Data Science Central in the Webinar tab located at the top of the page. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions. A special thanks to MariaDB for their sponsorship, and particularly our speaker, Shane Johnson, for his insight into today's topic. Now, this is Bill Vorhies. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on September 25th. Have a great day.